In question number 4, we're being asked to factor the given polynomial, and we're also given a hint that one of the factors is x plus 1. Now, because this doesn't really behave like a normal factoring problem, it's not set up like a diamond problem, we don't have perfect squares or anything convenient like that, that means our only choice is to use division. Because they're giving us x plus 1 as a hint, that usually means that when we set up our division, x plus 1 will be that part on the side. In order to divide this, we'll have to use this whole given part as the bottom, 2x cubed plus x squared minus 2x minus 1, so that our extra factor, the one we're looking for, will come out across the top of our division. As we set up our division, we always start with the first term, 2x cubed, and we work with the box backwards. We need to find a number on top so that times x gives us 2x cubed as the answer. We know that would be 2x squared. You can always check 2x squared times x should be 2x to the third. Now if we take 2x squared times the 1 on the side, that would give us 2x squared inside the box here. Now the whole point of the box, when we set it up, is to get like terms on the diagonal so that those two like terms add up to the term at the bottom that we were given. So we need 2x squared and something to be positive 1x squared. Well, the only way that would work is if this was negative x squared, because 2 minus 1 is 1. If that diagonal term had to be negative x squared, that means the term on top would have had to be negative x, because negative x times x is negative x squared. If we have negative x on top times 1 on the side, that would give us negative x. And again, we look diagonally, because we need that negative x times its diagonal partner, added to its negative partner, to be negative 2x down here. Now, negative x and something to be negative 2x, well, that means this would have to be negative x itself, because negative 1 and negative 1 makes negative 2. If we're looking now, we have on the top must be x minus 1. Must be minus 1, because negative 1 times x is negative x. Negative 1 times 1 is negative 1. And we know our box works successfully because that number matches what we had on the bottom. It's a good thing because when we're asked to factor, we shouldn't be getting remainders, so that's an easy way to check. Now, we know that one of the factors was x plus 1, which we used as the side of our division. The other factor is what came out on the top of our division. Now, the interesting thing is that the top of the division, 2x squared minus x minus 1, is itself factorable. So when we're being asked to factor, that usually means we look at our answer and ask ourselves, can we factor that further? In this case, 2x squared minus x minus 1 is a diamond problem. So it's our job to recognize that's a diamond problem, and it's our job to complete that diamond. That means if we're doing a traditional diamond, the number on the top of it would be negative 2, and on the bottom would be negative 1. It's our job now to find numbers that multiply to negative 2 and add to negative 1, and it looks like negative 2 and positive 1 would work. Now, depending on how you learn to factor, there are lots of different ways, but I'll show the way I show in my class. That means we have to take our original our original polynomial there, and we need to split it up. We'll keep the first term the same, we'll keep the last term the same, and we use our diamond to split up that middle. So instead of negative x, we're going to call it negative 2x plus 1x. Again, according to the diamond. We're going to use that method called grouping, where we divide up our problem into two separate, smaller groups, and we look at what each group has in common. 2x squared minus 2x has 2x in common, and if we take that out, that leaves us with x minus 1 left over. In the second group, 1x minus 1 has positive 1 in common, and if we take that out, we'd have x minus 1. Since x minus 1 is common to both of those groups, that means x minus 1 is one of our factors. And what's left over, which in this case is 2x plus 1, is the other factor. So now it's our job to kind of step back and think big picture. We were given one of the factors originally as a hint. Now we've gotten two more factors from doing the diamond problem. So altogether, we should have 3 factors. That makes sense because when we look at the original problem, it had x to the third. X to the third means there should be 3 x's, and since we know we factored them, we know we have them all accounted for.